The sampling frame is the list of individuals or items in the population. From this, a subset can be obtained using various methods. Some methods are better than others, while at times it depends on other characteristics as to which type of sample is best to obtain. Definitions and examples of different types of samples follow. A simple random sample, or SRS, is a sample of size n such that each group of n items has an equal chance of being selected. The steps are: number 1, define the sample size n. Number 2, for each different group of size n, assign a number. And then 3, use a random number to pick one of the groups. Now, an alternative method that is often used says to number 1, define the sample size n. Number 2, list all the elements or people and assign unique numbers to each one. And then randomly pick n distinct elements or people from the sampling frame. For example, I want to select a simple random sample of 50 students from current Stat 205 students. Suppose there are currently 625 students taking Stat 205. So list all the students, then assign numbers from 1, 2, all the way up to the number enrolled, 625 in this case. Use random numbers to pick 50 from this group. I would then locate the names and contact info for these students to collect the information. The key to identifying a random sample such as this one, which is a simple random sample, is that all people or items are in one big group and everyone or everything has a chance of being selected. Stratified random samples. This is useful when lots of variation exists in the population, but categories exist within the population for which the variation in each category is smaller. In geology, you would think of the layers in the earth. Lots of variability exists in the earth as a whole, but each layer has similar characteristics, or the layer is more homogeneous than the earth as a whole. Then sample in each layer. These layers are called the strata. Suppose your goal is to measure the opinion on a political topic. Suppose your population consists of 50% Democrats, 40% Republicans, and 10% other. Notice if a sample consists of 300 Republicans, 50 Democrats, and 50 others, this may give an inaccurate representation from the population as a whole. How do we attempt to apply this type of sampling scheme? We create categories, or what we call strata, which consist of political preference. So a Republican stratum, a Democratic stratum, and then an other stratum. How would a sample of 400 people be selected? So the three strata, again, are the Democrats, Republicans, and other. Now split the 400, and one method is proportional sampling. So Democrats were 50% of the population, so 50% of the sample of 400 would be 200 Democrats. Republicans, which were 40% in the population, so 40% of 400 would be 160 Republicans, and other, 10% of 400 is 40. Then select a simple random sample within each stratum. Randomly sample 200 Democrats from all Democrats, randomly sample 160 Republicans from all of them, and randomly sample 40 others from all of others. A stratified random sample may be more representative than a simple random sample, but it's a little more complicated mathematically to produce estimates. Key to identifying a stratified random sample: different groups are identified. A small part or a sample is collected from every one of the groups. The cluster sample. A cluster is a smaller subpart of the population which has similar characteristics or patterns as the whole population. An example might be a county which has similar racial diversity as an entire state. These clusters are heterogeneous. They have variability like the population in terms of some non-measured characteristic. This is different than the strata, where each stratum has homogeneous patterns in the non-measured characteristics, such as mostly or all one race, mostly or all one political preference, or all one socioeconomic class, and so on. The method is to identify multiple clusters, sample some of these clusters, and take a census or observe all people or items within the cluster. Example: suppose you are interested in housing characteristics, specifically the sizes of houses in northern Kentucky. Suppose clusters are subdivisions, of which you can identify 250 clusters. Randomly sample 20 clusters. Within each cluster, record the size of every house within that cluster or subdivision. The key to identifying a cluster sample is that different groups are identified. A few, not all, groups are selected where every person or item in those chosen groups is observed. Now consider the systematic sample. This is recognized by a system which exists to observe a value in a very patterned way. This is accomplished by examining a certain observation in every group of several things. It's often described as starting at some random location and then observing every nth person or item or thing. You may use a random number that says start with the 7th item, then you systematically observe every 5th item from that point on. So observe items 7, 12, 17, 22, 27, 32, 37, and so on. Here are some other examples. Suppose a manufacturing process produces hundreds of products hourly. A systematic sample might examine every 15 package, beginning with the first to ensure seals are closed. Another example could be examining the performance on an assignment in English 101. You might start at student number 3 and observe every 7th student in the total list of all students taking English 101 this semester. Or you might observe the make of every 5th car in a parking lot. The key to identifying a systematic sample is that you observe every nth item. Next is the voluntary response sample. In this sample, the respondents must take the initiative to reply. An offer to participate can be made, but it is up to the individual to take the initiative, to volunteer to give a reply. Examples: RateMyProfessor.com. The happiest and most disgruntled students tend to give ratings. Votes on shows like American Idol. customer satisfaction surveys at a restaurant. The key to identify a voluntary response sample is an offer to participate is made. The person has to make an effort to participate. Finally is the convenience sample. In a convenience sample, the person collecting the information uses a sample that is easy or convenient to select. Examples: the makes of cars in the first row in the parking lot, less walking around. The students sitting in the front row in a class. Easy to speak to these students for the teacher. The ages of people who live within 5 houses of me in my neighborhood. I may already know them, and I don't have to go very far. Or if I don't like speaking with people I don't know, it's more comfortable to talk with people I have seen and likely spoken with before. The key to identifying convenience samples: it's easy to get the sample, not as much work as a simple random sample. Not everyone or everything really has a chance to be included. There are challenges in attempting to gather information through sampling. One challenge is under coverage, which implies a situation where there's missing information. This can result from a poor method of selecting the sample or other circumstances such as non-response from people. Examples of under coverage can be if you mailed out a survey but people did not respond, or you emailed a request to complete a survey but people do not fill it out. Another example where under coverage can occur is if you make phone calls but miss families because they do not answer questions. You call during dinner time or bath time. Another challenge is bias. Bias implies the responses are not representative of the entire population. As we seek to gather information in a study, we need to be aware of bias. This can be the result of a sampling method which tends to over or underrepresent some groups or some characteristics of a population. In sampling for political elections, if a sample relies on memberships to expensive clubs or magazine, periodical subscriptions during a financially difficult time period, such as the Great Depression, results can be incorrect. For example, Dewey versus Truman. A well-known example of bias in history occurred when the Chicago Daily Tribune printed an incorrect headline based on a poor sample. The headline reads, "Dewey defeats Truman." But notice Dewey did not become president. This headline was based on biased data. Be sure to review the examples and pay special attention to the ways to distinguish the different types of samples as we close out this information on topics in sampling.